Yeah, test. Check 1, 2, 3, 4, 5. Anyways, let's do it without the clicker. Should we get started, I think? Right. Perfect. All right. All right, some folks are still moving in, so I'll start slowly with a quick introduction. All right, so my name is Nitschinger. I work for Couchbase as a software engineer. I'm more or less responsible for everything that's happening and going on the JVM related to Couchbase, together with some of my colleagues here, which are also around. So this talk is going to be about RxJava and actually how to query data out of Couchbase together with RxJava. So that's basically what we're talking about. You can also find me on Twitter if you want to. I'll be regularly tweeting about everything that's related to Couchbase, programming, and all those things. So let's do a quick show of hands first. Who has used RxJava already? Okay, and who has not heard about RxJava at all? All right, great. So what I want to do first is give you a quick motivation of why we actually need this reactive, event-driven style programming model. And then we'll basically go deep dive into how Rx works. And then I'll show you how to do that, basically how to query asynchronous data out of Couchbase with RxJava. So first, why do we need a different style of programming, right? We are all used to blocking operations, doing a call, waiting for it to come back, and then proceed. And the reason for that is that what I'm seeing out there is we're facing more and more challenges in terms of reacting to user load, reacting to failure. And the most important part is you want to be responsive under both load and failure. And the problem for that is that our current programming model with blocking operations tends to be not the most optimal solution for that, because every time you block on a thread, you're actually allocating resources to the thread, which could be basically routed to doing something else, right? If you do a network call and you're waiting like, let's say, 10 milliseconds for the response to come back, that thread actually waiting could do some other computations, could take another request that's incoming, perform computations, and so forth, right? So the idea is to go from a pull-based model to a push-based model, where the client tells you, hey, I'm done with my operation, then you can do something with the result, right? You're not waiting, you're not keeping your threads and wait for network operations, because as we all know, a network operation takes much, much longer. For one network call, basically, we could do hundreds of thousands of actual in-memory and CPU computations in the meantime. So those new challenges, they demand new solutions, and one of those solutions is an event-driven programming model. And there are also other based systems like actor-based systems, which are also great. But in the end, at least in my experience, it always comes down to decoupled event-driven structures, right? In the most ideal case, all you have is independent actors, and they communicate through messages. They're sending messages from one to each other, and events are generated, and you react to events. This shared nothing architecture gives you lots of possibilities. It allows like the JVM to move stuff from one thread to the other, and you don't have to care about that, right? So you can use your resources as much as possible. That's the most important part. Or if we want to put it in one meme, latency is too damn high with the current solutions out there, so we should do something else, right? Let's go event-driven. So let's do a quick detour on how the Java client in the core itself is implemented to show you how we are doing asynchronous from top to bottom. Because the problem is you could stick RxJava on top of a blocking API, but it's half the fun, right? Because you've already blocked. The good stuff is already gone. Is it like to say you can always go from a more powerful concept to a less powerful concept, or you can always go from asynchronous to synchronous by blocking, but you can never go the other way around, right? So what we are doing in the Java client is, if a request comes in from your application threads, it's actually never talking to our I/O layer directly. What we are doing is the messages get put into a request ring buffer, which is a fixed size, so we can do something like back pressure as well, which I'll talk about later as well. So that the requests get put into the ring buffer and they stick around there. And then there is a different thread which will take all those requests out of the ring buffer from a different thread, locate the proper node, the proper service, and so forth. And eventually it will write it down to the socket. And then the database will perform the query or a key value and return the result. And then we'll push it into another ring buffer so we can decouple our I/O loop, which is down here, completely from the application threads. Because what we don't want to happen is that, let's say you block on a callback and our I/O loops are completely swamped, right? We don't want it to happen at all, right? We really want to move the application concern away from the core library, right? And this is a good way to do that. And by using ring buffers, we can do something which is called smart batching, which is a great side effect of decoupling producers and consumers. Now, imagine for a second we would let your application thread talk to our I/O device. Let's say, so we're using netty asynchronous I/O loops underneath. We would let them talk directly to the net event loop. Now, what we'll get there is lots and lots of contention, but also we would not benefit from any batching effects because your application threads are not coordinating with each other. They're just writing down to the I/O loop as the requests come in, which is not very beneficial. Now, if we put a ring buffer in between, what we can actually do is we can decouple the application thread from the batching thread. And imagine the application threads are faster than the batching thread. Now, let's say you are pushing like 100 messages in, and our I/O thread here can only handle 10 per second or something like that. So when it comes back the next time, it will find more requests already in the ring buffer, so it can take all of them out at once and put them on the network at once, which means that we can mitigate overload effects by getting better batching effects on the TCP stack and so forth. So by using the proper data structures here, like a ring buffer, we can mitigate overload effects and also reduce contention, right? So that's a great thing. And the other thing is back pressure. I don't want to go into detail on back pressure in this session. There will be a session called Ship It tomorrow, which will talk more about error conditions. But one thing you'll notice here is that if the ring buffer is full, we can immediately tell the application thread to back up, right? And this is quite important. This is a very, very important part of a distributed system or a library that is accepting requests, that at some point we're telling you, hey, you overloaded the system. Instead of just keeping accepting requests and making all of them slow, those we accept can go through fast, and those who overload the client will be rejected immediately, which gives your application threads, in turn, a chance to decide what to do. You can propagate your failure, or you can intelligently retry if, depending on your SLA, that works out or not, right? All right. So let's talk about RxJava. Let's do a quick RxJava 101 for those who have never heard it before. What is RxJava? RxJava is a Java implementation for reactive extensions which originated from the .NET platform. So the concept of RxJava, or the API that you'll find out there, if you use Rx on .NET, and there is also Rx JavaScript and so forth, the APIs look very similar. The concepts are the same, but of course the implementation details vary. And what RxJava or all those Rx solutions provide you essentially is basically a library to compose asynchronous and event-driven programs through observable sequences. Now, if we take that into a Java analogy, basically, if we say let's say we take a synchronous call, a method call, we call we have an interface where we call a method which returns as a variable. If we do it synchronously, we get that object returned, right? Of type T, we get the response. Now, if we do that asynchronously, we'll get a future of type T. The future, which is part of the Java util concurrent package, it's a pain to use, right? Everyone who's tried to use the future interface in Java will know that it's very hard to use, especially it has no callbacks and so forth. So everyone is extending it on their own, and RxJava actually provides you a way out there, a very sane way out there. Now, if we talk about getting multiple objects from an API, right? What we do in a synchronous fashion is we use an iterable, right? We call a method, we get an iterator back, and we iterate through the iterator, and we pull out the values, right? And the observable is nothing more than the asynchronous cousin of the of the iterable, right? But instead of having a pull-based model where we are pulling data out of the iterator, in an observable, we get notified once the data is available, right? And since the more powerful concept, the asynchronous one, can turn into a blocking one, you can always convert an observable into an iterable, right? If you want to block at some point, you can modify, or you can transform the observable into blocking observable and extract the blocking iterator, right? You can always do that. All right. So let's look at the different events that can happen in an observable and compare it to an iterable, because I feel most of you are already familiar with an iterator. So if we want to retrieve data out of an iterator, we call the next method, and we get our item out of the iterator. If an error happens, well, it will throw an exception, right, and we can catch that. And if our iterable is empty, right, we consumed every item out of the iterator, it will just return, right? And if we compare it to an asynchronous observable, we are not calling on next, we are not calling next on the iterator, but actually the onNext method will be called from the source of the observable and notify us that an event arrived. Now, since we are in a completely asynchronous way, there is no way to throw an exception because we are potentially operating on a completely different thread. So what is actually happening is that an error event is generated, which calls the onError method on your subscriber, then you can do something with the error, right? And RxJava provides very sophisticated error handling mechanisms which you can use to do something like go to another observable if an error happens, return a static, fallback, and so forth. And then finally, if our observable is complete, which doesn't have to be always the case, right? You can also have an infinite stream. Your observable could also be never done. Imagine you're doing a mouse click tracking on your application, right? The mouse is moving all the time and clicks are happening, so the stream never ends. But if it ends, like if it has a finite number of items, the onCompleted method will be called. So how can we consume data out of our observable? Well, here we are using the .get method on our bucket. So we retrieve a document out of the database. And then we call the subscribe method on our observable. And the subscribe method basically takes a subscriber, and the subscriber implements all those three methods we just talked about. OnCompleted, onError, and onNext, and you can handle them, right? You can do something with them. Keep in mind that here, even our RxJava itself is not bound to any specific multi-threading or something. Here, because we are doing network calls, our subscriber will be called on a different thread than it was called, right? So if you do a public static void main, you just put that code in there, you're going to see nothing, right? Because the main thread exits, because this is called asynchronously. There are ways to do that. You can block or you can sleep and so forth. So there are many ways to do that. And this is just a very simple example on how to implement an observer. So we now know how to subscribe to an observer, but we also need ways to create observables, right? In the context of the Java SDK with Couchbase, those observables are created for you, but if you're building a fully asynchronous stack, you also need to create those observables on your own. And there are many factory methods you can use, so convenience methods to create observables in a very easy fashion. The probably easiest one is the just method, where you're passing in a list of values, and they will be immediately emitted. Now, what you see on the screen here, it's called marble diagrams, and they are a very simple way to represent observable streams. So at the top, you can see we're passing in a list or a collection of data into our just method, and eventually it will emit events, and then the final element that you see there is basically the onComplete event, right? So we have 6 onNext events and then a final onComplete event. And onError event is depicted with a red X. So how does it look like in code? Well, we can call observable.just, pass in the strings ABC, and then our subscriber. And here we are using an overload of the subscribe method. We don't always need to implement all those three methods always, right? Here we are only implementing the onNext method. And we say, we just print out the value we got. So this will immediately print out got A, got B, got C, and so forth, right? So this is a very easy way to turn any data structure or a list or an iterable into an observable stream. Another factory method is called interval. So you can create or you can emit items into your observable at a given interval. Here, for example, every second, it would emit an item into the observable, and then you can react to it. So for example, we say observable.interval, and then 2 seconds, and then we subscribe to it. Here we see a Java 8 method reference. I'm mixing and matching Java 6 and Java 8 syntax throughout the slides, so you get a feeling, especially if you haven't worked with Java 8 before. RxJava and the Java SDK support Java 6 and above. But if you're one of the happy ones to already use Java 8, just as a quick note, I think Oracle even deprecated support for Java 7 if you don't pay for it separately. So you probably want to move to Java 8 sooner than later anyway, just as a side note. So we're subscribing here, and what will happen is that every 2 seconds we would see printed out on the console like 1, 2, 3, and so forth, right? Now all of those methods, and there are many, many more out there, but I'm not able to cover all of them in this section here, are basically wrappers around the create method. And the create method is the only way to create an observable, right? And what is going on there is that you call observable.create, and every time someone subscribes to your observable, this this callback will be called, and you get a reference to the subscriber. And on the subscriber, you can call on next, on completed, on error, right? So this is basically the other side of the equation. So you're pumping data into the observable, and the subscriber on the other side is consuming it out of the stream, right? One important thing here to note is that by default, those observables are called cold observables, right? Which means that if no one subscribes to observable, nothing happens. This is quite important. You always need to subscribe to such an observable because it's lazily evaluated. And it also means that every time someone new subscribes to it, so you can have 10 subscribers, the full sequence is executed completely again over and over again. And now, in comparison, there are also hot observables, which are emitting items regardless if someone has subscribed or not, and independently if 10 or 20 or just one subscriber is subscribed to the hot observable, always the same item will be emitted, right? So there is a subtle difference. In general, you will use cold observables nearly always all the time. There are specific use cases with hot observables. In RxJava, they are called subjects. Right. Now, creating them and subscribing to them is fine, but we don't really get all the things, all the possibilities we can do with observables. The really nice thing is that we can transform them, we can filter them, we can do lots of different operations completely asynchronously with our data. Probably the easiest operation, or one of the easier ones, is map. And what map does is it maps from one type to another type, right? Imagine we are passing in string events, and the map function returns string into integer. For example, it counts the number of characters in our string, and then it returns the integers as the resulting observable. Now, important here, the source observable is never changed, right? You're creating a new observable which has the map function included, right? So you can have one source observable and then have different operators on the same observable and do something with them, right? It's not the same one that is changed. Think of your observables as immutable data, right? Immutable objects, and every time you apply a transformation, a filter, and so forth, you get a new observable stream as a result. So here we're using map, and again we're using the Java SDK here. We are loading a document out of the database, and then because the document, as you've probably learned in the workshop yesterday, and you'll see throughout the next 2 days as well, a document does not only contain the content, but it also contains document ID, it contains the case value, and so forth, right? So that's part of the document. But here in our case, we only care about the content. So what we do here is we map from the JSON document, in that case, just to extract the content. So our subscriber down here has no clue that actually the client returned as a JSON document. All it is concerned about is, hey, I'm caring about the content, right? And you can probably start to imagine that if you're building interfaces, asynchronous interfaces in your code base, you can very nicely compose those interfaces because the downstream subscriber, the downstream component, doesn't need to know what's going on upstream, right? And this is a very important distinction to blocking code, right? Imagine you have an interface where you're doing a network call, a blocking call. You just return type T, or you write the implementation and by start you just grab the data from an in-memory hash map, right? You return type T instantly. And then after half a year, you think, oh, no, I probably need to go somewhere else to grab it from a database or an external service. What are you going to do now, right? You either need to change the interface, or your API doesn't depict that actually you're now going from like a half millisecond call to maybe 10, 15, 20 milliseconds, right? And there is nothing you can do about it. If you use observables, since observables tell you right away that there is latency in there, right? And they don't care about that in an API fashion. You can gradually go from, let's say, an in-memory lookup with observable just to a database network call, and your API or the downstream component doesn't have to care about that at all, right? It makes it much easier to transform APIs in a very nice fashion. Another operator is flatmap, and you'll run across flatmap a lot if using RxJava. And I understand that in the beginning it's very hard probably to understand what's going on in there, but you can imagine what it's actually doing. It's not mapping from type A to B with a map call, but it's actually mapping from type A to observable B, and then it puts those all back together. Now, as an example, imagine you're using observable.just to put in 10 document IDs which you want to fetch out of Couchbase. And then you use flatmap to map from the string to a JSON document. But this is, of course, a network call, an asynchronous one. So you will get observables returned from the API as well, right? But downstream, you don't want to have observable of type T, right? You want to have that flattened together into an observable of type T again, right? So this is what's going on here. So it's mapping the type, but it's also flattening the returning observables into one observable stream, right? So to give you a concrete example, and this again is Java 8, and we'll walk through that line by line to give you an idea. So here we're doing a view query. And the view query, again, is another type of a secondary index you can do with Couchbase. And we're querying our view, which is called beers, and we query by name. And we want to only get the first 100 records out of that view. Now, what we get returned is a result object. And the result object has like a status code and so forth on it, but it also has a rows method. Now, in our example here, we don't care about the status. All we care about is the rows that are streamed back from the server. And as a side note here, the Java SDK actually implements a JSON streaming parser under the covers. So as we query the data, and you get an observable returned, and you call flatmap here, an item will be emitted as soon as this arrives from the server. We are not batching up the complete JSON result. We are trying to feed them to your application thread as quickly as possible, right? So here we are saying, okay, we get the result, it's fine, but all we really care about is the rows that are in there. So we use flatmap to map from result to the rows, but since the rows are not observable again, right, we map that down. And then there is another method you can call, which is called document on the row. And if you've worked with views before, you know that probably you get an ID, a key, and a value, but in general, you don't want to put the full documents into the view rows because it's just duplicating data. So what you can do here is you can call .document, which will, under the covers, do another like primary key value lookup on the document and load the document for you, right? So here, at this point, at the second flat map, we basically already did like 101 network calls, right? But the filter method here has no clue that we actually did over 100 network calls asynchronously, right? Another benefit of that is because flatmap is unordered. You can think of it like as fanning out all those 100 binary GET requests to the server and return them as quickly as possible, which means that if you would compare that to blocking code, you would loop through that, you would do one get, and so forth. And here we are basically doing 100 gets in parallel, taking them back in any order they come back, and then pass them down the stream, right? Much better resource utilization, a more effective way of dealing with your data if you care about latency and throughput. Now, the next method here, we're using a filter. I didn't introduce filter before, but you can think of it as a simple predicate, right? So every item that you pass in through your observable stream gets evaluated in the predicate. So we say only if the content of the document, our beer, has an alcohol by volume greater than 5, we let it pass through. If it's lower than 5, RxJava is just going to not emit the item downstream. And then we are applying another operator, which is part of RxJava, which is called count. And count is counting all the items that are emitted. And then there is another operator, which is called timeout. And here we are applying a timeout of 10 seconds to the whole thing. And this is very subtle, but it's very, very important. We are doing over 100 network calls, and we are applying one single timeout to the whole operation. Everyone who's tried to do that with blocking code, it's nearly impossible, right? How are you splitting up your timeouts in blocking code, right? Are you dividing that by 100, so you have 100 milliseconds, but then how are you going to handle network outliers and so forth? Applying one single timeout to such a, I would say, and it's quite a complex type of operation that's going on, right? Applying a single timeout constraint to the whole thing is very, very powerful. And you can chain those timeouts in where you want. You could even add another timeout to each individual network call, to each document call. So you could say, the whole thing should take maximum of 10 seconds, but I also want to make sure that the binary get call only takes like 1 second. And if not, I'm going to, for example, on error return with a static fallback, right? So you have very tight control of error handling, which we'll see a little bit later as well. Another operator where you can transform observers is called group by. And group by basically allows you to take your input data and group it by a key that you define. And the outcome will be different observables, which are based on the key that you identified, right? So here we have triangles and triangles and circles, and all the triangles get one stream, and all the circles get another stream, right? So let's do a concrete example again. So here we are performing a nickel query. We say select star from beer sample. So we are here selecting all the data out of a beer sample bucket. And then we use flat map, again, because we get a result object, but we want to extract the rows that we get from our back from our nickel query. We extract all the rows, and then we use group by to group it by the type field in our JSON document. The type field here can be beers or breweries. So what this code ends up happening is our subscriber gets called, basically the grouped thing here, are two observables, one observable stream for beers and one observable streams for breweries. So, and we are printing out the result here, and we're counting all the streams. So in the end, this code will asynchronously print us out like there are 3,000 beers and 4,200 breweries or something in our beer sample bucket. Right. And there are more operators like merge and join, so you can, of course, merge different observable streams back into one and then keep going, right? That's also possible. Another way to transform observable is buffering. So what you can do is you can, sometimes you don't have control over what items are omitted inside your stream. So you can use buffer to basically batch those documents or batch those events together and then react to them in a batching fashion. Right. So this is especially important for, let's say, hot observers. Imagine you have a click stream, someone presses buttons on your UI, and you don't want to send every event all the time over the network. You probably want to wait like 1 second. You can also, here you can buffer on a count, but you can also buffer on a delay. You can say buffer all events together for 1 second, and it will emit all those events in a 1 second batch. Here's an example where we are simulating traffic. We use the interval method to generate an event every 100 milliseconds to basically simulate data that's incoming into our observer every 100 milliseconds. And then we're using buffer to buffer all those events on a 5-second interval, right? And then we use flat map to take all of those IDs that we got returned, map them into a document ID. So here we are mapping them into a string like ID 1, 2, 3, and so forth. And then we are calling get on our bucket API. So we use flat map again. And then here you can see that the blocking call, right? This is basically how you can convert an asynchronous stream into a synchronous one, just as an example. But here we're basically, what we end up doing is running get calls every 5 seconds. And if you look into the Couchbase UI, what you'll see is something like this, right? Every 5 seconds, you get an operations per second spike because RxJava is batching up our traffic. It's basically buffering it every 5 seconds, then sending it over to the network so you can batch an incoming data source quite nicely. And you can see it's basically just 2 operators, and suddenly you have your traffic batched up, right? Completely asynchronous and a non-blocking fashion. We talked about filter before. Filter allows you to specify predicate, and everything that satisfies the predicate is allowed to pass through, and the rest will be dropped. And here I've used Java 6, 7 method syntax again, so you can see it doesn't have to be always Java 8. Right? It's a little more verbose because you're passing in anonymous objects, more or less. So we are using just to basically to create an observable stream of 3 strings. And then we use flat map and call get, again, our bucket. So we are mapping from a string, which is our document ID, to the actual document. And then we're using filter, and we only let pass through our observable stream if the content contains the key foo, right? Only those documents allowed to pass through to our subscriber, the rest will be dropped, right? This is how I can use filter. And there are many, many more methods available. For example, there's first. With first, as you could probably guess, the resulting observable stream will only wait for the first item, and once it gets the first item, it unsubscribes, right? So a practical way to do this is that on our bucket API, normally what you do is when you do a get call, we go to a specific partition and grab the document from there. But we also allow you, if you want to treat availability for consistency explicitly, you can get from replica, right? So you can fan out to the replicas that you've defined and say, give me the data from the replica, right? It might be stale data, but maybe in your use case it fits, right? So what we're doing here is we're saying, get from replica, document, and then replica mode all says, go to all replicas that are available, right? So in the end, what will probably happen is that we'll get 0 to 3 results, depending on how many replicas we've defined, how many replicas are available, and so forth. But maybe our API downstream only cares about the document. It doesn't care about 3 documents that got returned. So we can use first to just grab the first document that gets returned from the server, right, and just move on. And the rest will be dropped because we don't care about that anymore, right? All right. So that was a very, very quick tour into RxJava. There are many, many more operators available. I recommend you to check out the website and try out all those things. And we have also on the Couchbase server documentation. I wrote a documentation piece which is called Mastering Observables, which talks about all of that in detail, and you can read through that and go from zero to basically understanding them. All right, so let's talk about reactive nickel. And we briefly covered RxJava with nickel queries, but let's talk about that in a little more detail. So we have three query types in the Couchbase Java SDK. We have simple queries, which are basically executing a nickel query right away. There are parameterized queries where you can decouple the query itself from the params you're passing in, so you can use named params or positional params. We'll see that in a bit. And then also prepared statements, prepared queries you can use to cache a query plan and then avoid the query plan creation every time you do a query. Now, we did flat map to extract the rows from the query, but how does the response object actually looks like? Well, you can see that on the asynchronous API, and I grayed out the observable because what we're doing in the Java SDK is everything is asynchronously, and the only reason why you get a synchronous API is because we just block on all those asynchronous calls, right? We can very simply provide you a completely blocking API by just applying a timeout and blocking on the call, making it from asynchronous to synchronous. That's all there is to our synchronous facade over the asynchronous API. So the result has, for example, a rows method, which you've seen before. It's like emitting all those rows as they come along. There is also an errors observer, which if the query failed for some reason, you'll get the errors there. There is info, because JSON, so the query engine returns you some informational data which you can use. There is a signature object where you can pass in some arbitrary stuff and it will return them to you. Same with the context ID. And then there is a final success which you can use, because since this is a complete streaming query, we need to differentiate between success like a HTTP 200 coming back from the query, but there could also go something wrong during the query, right? So this is where final success come in. If everything in the whole query succeeded, final success will be true. And then there is a request ID which you can read and so forth. So how does a simple query look like? Well, we call bucket.query. We pass in our query like select star from travel sample, and we limit that to 10. And then we flat map, we extract the rows and print them out. We've seen that before, and as a result, you'll get all those items emitted. And the for each here is actually a shorthand. It's like the subscribe with only passing in an action for the onNext method. You can use for each to more clearly describe that your subscriber, your onNext method, your callback here will be called for every item, for each item that is omitted. Parameters queries are very similar. The only difference is that in addition to the query itself, you're also passing in, here we're using named params. So you can see that where type equals $type. And then we create a JSON object which acts like a map, and then we say type equals airline, right? So you're basically separating the query from the actual params that are passed in. And then again, we're just printing out the rows. And then there is also the parameters query with positional arguments. So you, instead of saying $airline, for example, you can say $1, $2, and so forth. And then instead of passing in a JSON object, you're passing in a JSON and array, and then all those arguments are basically put in the query depending on the number that you're passing it through, basically. Right. And then finally, prepared queries here. So we can call bucket.prepare, pass in here we are using the raw nickel string, but you can also use the builder API depending on what you want to do. And then we are calling flat map on our query plan, because the query plan is created once, and then we call bucket.query with our query plan, and then we emit those items. And here I did a little variation so that you see something else. There are also methods called doOnNext, doOnComplete, and so forth on the RxJava API. And what they do is they are pure side effects, right? So everything you put in there is actually meant as a side effect, right? So here, for example, we are logging the error, right? You cannot mutate the observable stream as part of those methods. Because there's a common error. People try to do error handling with the doOnError method, but there's actually onError return, onError resume next, and so forth. So the onError methods are used for error handling, while the doOnError is just a pure side effect. So a few more examples. Index handling, for example. We can create a primary index as well with an asynchronous call. So you can say create primary index on travel sample. We're using the index type global secondary indexes, which you've seen in the keynote as well. and then we are printing out if there's an error. We are extracting the info here. So in this case, we are not concerned about the rows, but we want to get the info object, which returns us some information if the index was created properly and so forth, and print it out. And then what we can also do is we can use something like select indexes from system indexes where key space ID equals traverse sample, which means that this query will list us all of the indexes that are created for our current bucket, right? And then we are extracting the rows. We are mapping from the row to the value, which gives us the actual JSON object out of the response. And then we filter if the type is GSI, which means that we only care about the global secondary indexes. And then we extract the name and print that out, right? So what this thing here will do, it will give us an asynchronous list of all the names of our indexes on our bucket, right? So you can see how to compose those queries in a very nice fashion. And here is a more complex example before we go to error handling and then wrap up. Conditional index creation. So we're performing a query, again, like the one before. We select all the indexes from our current bucket, and then we extract the rows. We map the complete row just to the name because we care about the index name. We filter if, for example, only, so if this index exists, it's passing through. If not, it's stopping, right? And then we use a method called switch if empty, which means that this method will only be called if the index does not exist, right? Because all the other indexes will be dropped only if that index doesn't exist. Then we switch if empty accepts another observable, right? Which is again a bucket query. So RxJava basically routes these requests, the create index statement only if the index doesn't exist, and then we then again subscribe. So you can see you can really build flows depending on the state of your system in a completely asynchronous fashion, and you can use timeouts and so forth, again chaining those operators in as well, right? So very powerful concept. So the last thing I want to quickly touch on is error handling. So there is another session tomorrow on which we call ship it, building applications for production. But I quickly want to touch on error handling. It's one of my favorite topics. So the first statement is quite important. Things will go wrong, so please prepare for it, right? So there is no question that things will go wrong. It's just a matter of when it's going to happen. And the second one, I really emphasized it. Do not trust your integration points, including the SDK. I'm working on the Java SDK, and while it's a great piece of software, I'm sure, it has bugs, right? Things go wrong. We make mistakes. So even don't trust that, right? Make sure you have timeouts in place and so forth to have last lines of defense, implement proper error handling mechanisms, and so forth. And again, synchronous retry and fallback is too damn hard. I've tried that hours and hours, and it's really hard to get right, especially if you do only synchronous code, applying timeouts to them, and then falling back to another sequence or retrying the whole thing. It's very hard to do. And with RxJava and asynchronous streams, it's very easy. Let's say it's not easy, but it's easier, right? It's much easier. You still need to think about the whole thing and reason about it, but it's manageable, right? And RxJava out of the box provides you things for doing that, yeah? Fallback, retry, and failing fast. It's basically provided out of the box for you. So timeouts. Network is unreliable, servers fail, the SDK contains bugs, right? You always want to apply a timeout, right? Always use the timeout operator. There is no reason at all to not use a timeout. So, for example, here we are applying the timeout operator. You've seen it before. And especially if you are using, for example, our Synchronous API, right? This is actual code from the Synchronous wrapper. All we do is we do the asynchronous get call. We apply a timeout. Then we call to blocking to transform it from an asynchronous into a synchronous one. And then we return the value. With single or default, you can either say if the document gets loaded, we return it. Otherwise, we'll just return null. This is why the get method returns null if a document doesn't exist, right? And one thing I've seen on the forum, so we created the to the SDK, and 3 weeks later, there was a forum post. And like, how can I make this work? And I looked at the code, and they used like timeout integer.max in seconds, right? Which completely defeated the purpose of applying a timeout. So always use timeouts, use reasonable timeouts. It's really your last line of defense. Here's a more complex example. We covered that before, right? But here from the context of a timeout. We're doing hundreds, maybe even thousands of network calls, right? We're crossing lots of system boundaries. And applying a global timeout really is your last line of defense if something goes wrong. Finally, coordinated retry. If something goes wrong, you can either fall back or retry. So you always want to fail fast. This is a completely different topic. I just want to put it in your head for now, right? If you're interested in that, let me know afterwards. You don't want to get your whole systems stuck and swamped. You want to fail fast and let the caller decide what to do with if something goes wrong. And an important thing with retrying is never retry immediately. Always retry intelligently, right? It's very important. Retrying immediately doesn't help. If a socket gets closed or whatever happens, retrying immediately, there is a reason why the operation failed in the first place. Immediately retrying won't help. It will just put more load on your target system, and there is a good chance you're just making it worse and not better, right? So how does fallback work? Here's another example with, we're doing a primary key lookup. We say, get the document by beer. And then if this fails, for example, the socket is closed at that moment in time, the server goes down, the primary server, we use onErrorResume_next to load the replica documents. And then we use first, again, to just, because the code downstream doesn't care about we did the first document or all of them, we just care about one, and then we extract the data, right? So this is how you can conditionally move to another observable sequence if something goes wrong. And then the last thing I want to mention is that RxJava has a method called retry when, but it's quite hard to use. And we've done, actually I have to give credit to Simon, who's working with me on the Java SDK. He did a great job on that. So we are now providing a builder API to very easily define how you want to retry. So you can say, if any of those exceptions happen, I want a delay with the delay you can give it. Like here we're using an exponential delay, but with an upper timeout of 5 seconds, because you can imagine if you have an exponential delay, you want to cap it at some point, otherwise you very quickly get into the universe of time, right? But we only want to retry a maximum of 100 times, right? And this is very simple to use. If you've tried to use retry when directly, you need to use nested flat map, and then you need to use observer timer to resubscribe and so forth. So this is all done, it's all handled for you. It's part of the 2.1.3 SDK and part of 2.2. And you should definitely go ahead and use it if you need retry. All right, thank you very much. Any questions? Yes, one? Can you speak up a little? Yeah. Yeah, so the question was if Reactor is the same thing. Yes, Reactor provides another event-driven implementation, right? It shares a lot of details with it. There are differences.